This is antilect, understanding the internal representations of large language models. What we've done this week is be able to represent neural networks as graphs, where the nodes are the layers in the neural network and the edges are the learnable weights. The method that we're using for constructing these parameter graphs is from a paper called Graph Meta Networks for Processing Diverse Neural Architectures. We can currently represent a couple of different types of neural networks as graphs. We can do linear layers, ReLU, some other nonlinearities, conv layers, and batch normalization. So here are some examples. This is a conv neural network where we have some conv layers at the beginning and then linear layers at the end with batch norm and ReLU thrown in throughout the network. And here's a linear network with ReLU in between the linear layers. I worked on primarily creating the software architecture to construct the parameter graphs and then putting together these visualizations and this front-end website. What's next for antilect? We want to generate a lot of different neural networks, construct their parameter graphs, and then train a graph neural network to reason over the underlying neural architectures for the parameter graphs. So we're going to take parameter graphs as input and then make predictions about the underlying neural network, such as how well it'll perform for a given task. We can even apply this to the activation space. This is an active area of research that we want to explore, and then also apply this to large language models. We can then reason over the representation space of these models and learn more about how they represent different concepts through their weights and their activations.